Namaskar. What are the limitations of present simple quantum computers? Was the question asked by few kids, or maybe even the some technocrats asked, because they remain involved into their everyday activities. They said, "Sir, please let us know." So here is the answer. You see, quantum computers are going to touch potentially every form of our life, every phase of our life, maybe every moment in our life. And we already know that not a single entity and not a single species is perfect in this world. That is why quantum computing also is not perfect at present, and it has some limitations. So within those limitations also we have to survive, sustain, and live a good life. That is very important. This technology should not go into wrong hands. Those who follow ethics, humanitarian values, humanitarian norms used for a humanitarian purpose, those only should get quantum computing technology. Okay, so what are the limitations? There is a limitation of manufacture. You know, many a times superconducting materials are required. So refrigerators and refrigeration mechanism are required. There could be dilution of refrigerators. One single moment we saw earlier, just 0.001 degrees Celsius also increase in temperature becomes very difficult, and that becomes interference in our calculations. So that dilution refrigeration is a big problem. Another is big lasers are required many times, because if photonic computer is there, a beam of laser with coherent and monochromatic and so many things are required. Simple change here or there is very makes it very difficult for monochromatic, coherent, and so many. That laser, everybody knows that light amplification by simulated emission of radiation, LASER. Okay, yeah. Then many times vacuum chambers are required, because if photon is going from here to here, that qubit is there, photon, it is carrying information from this place to this place. A vacuum chamber is there, there will not be any interference, it will not dash any to any particle. Creating pure vacuum chambers is sometimes becomes very difficult. So these are manufacturing difficulties. A lot of manufacturers are facing. Okay, then limitations to the error correction due to quantum noise. Last time we thought about it, quantum noise, and this quantum noise leads to some error. Already we saw, when I'm speaking, the metro is going, the highway is here, the railway lines are going from behind, the aeroplane is going from up. So a lot of noise is there. So noise interference is there, like that. A lot of noises are there. It is, quantum computers are vulnerable to errors because of these noisy things. May it be, if photon is going and suddenly another photon comes, dash. Simple. Like that, so many noises are. This is a noise. Noise doesn't mean, speaking loudly. Noise means these interferences by so many entities. Maybe sound, maybe magnetic field, maybe some particles, maybe some charge, maybe you name it. Even gravity can become noise sometimes. These errors get quickly accumulated and destroys the information passing through. And many a times, if series of photons are going and just one photon is been, one photon gets dashed with another one of the particle, it gets that particular information is destroyed. So that becomes error. So computational error occurs. So that is a limitation. Another factor is additional qubits limit the error correction procedures and techniques. Now, if that photon gets tapped, it got struck and it got deflected. So, how to create additional qubit then? How to correct that? Because a stream of photons should be there uninterrupted. It's very difficult to form a stream of photon exactly, one photon, two photon, exactly one behind the other, and all those things. So it is very difficult to get exact results, and final computation becomes a problem. And it is very difficult to devise such continuous process, difficult to devise and implement at present. In future it will be very easy. Somebody will find out a solution. It is always there. Next generation should outsmart the past generation positively. Okay, that should be there. So this is about limitations to error correction due to quantum noise. What are the noises we saw? It could be gravity, it could be the charge, it could be a dash of a particle, it could be anything. I mean, even noise, voice, and so many things. Even temperature rise, pressure rise, so many things are there. Okay. Next is limitations to scalability, calibration, and control. Scalability, everybody knows that computers are very small scale performing entities. Now there are limited operations are performed. In for example, in normal computers, limited operations are there. But in qubits, millions of computing operations are there. So how to control, how to match and mismatch? I hope you understand. Millions of computations and just few calculations are there. How to match this? So scalability is problem. So many times error could happen because it is a big challenge. Next is calibration and control. How to calibrate? A stream of photon is coming and suddenly some magnetic field and certain place, we don't know where exactly is happening. So how to calibrate it? I hope you know the calibration, that if the weight is there, we weigh the the vegetables and all those things. Then we put a container. After putting a container in which the vegetable has to be put, we set it to 0. How to set it to 0? This calibration, that is very big problem. And then we calculate 1 kg vegetable or 2 kg vegetable, something like that. How to calibrate? How to control that? So to calibrate and control, certain more qubits are required. So it means more energy is required, more calculations are required, better algorithms are required. So fourth is limitations to quantum algorithms and software development life cycle. Limited algorithm collection, range, and repertoire. Huge amount of investment is required because very few algorithms are there. Shor's algorithm and Grover's algorithms are there, which are offering better speed than classical algorithms. I mean, you might be knowing those algorithms. Then SDLC, quantum programming and complete software development life cycle, is still in an initial stage. So developing software can efficiently utilize quantum computers. It is a very big challenge. Limitations to quantum algorithms and SDLC. Fifth is limitations to quantum hardware development and material sciences. Quantum hardware limitations. To develop reliable, scalable quantum hardware for quantum computing is necessary, but it is vulnerable to errors at present with present material sciences technology. We have to have better hardware in the future. Better, the material science technology should be there. Better products should be there. Even 0.01 impurity. But in quantum computing, 0.01 makes millions of atoms. And we are talking about photon, one single photon and millions of atoms. I hope you understand how big the error could be. So that is the quantum hardware limitation. Material science challenges, already said, superconducting materials and, or topological insulators developing. Then, developing the optics, developing the proper magnets. There are so many other limitations are there. It's a big challenge. Sixth one, limitations of quantum supremacy and verification. Now, I'm giving you, on the lighter side, I'm giving you one example. And then we'll check this. Suppose quantum computer finds the value of pi, 22 by 7. We say 3.14 and calculate and go ahead. Pi is used in, the circle. Pi r square is the area of the circle, for example. So pi is 22 by 7. Now, the quantum computers find out that the final answer of 22 by 7 is 10 raised to 1000, 10 raised to 1137, something like that. But who will confirm that figure? Who will confirm? Now, you keep calculating 10 raised to 1000. It will take at least 100 years somebody to write down, find out something like that. Just on the lighter side. Who will confirm that? Okay, so limitation of quantum supremacy and verification. Demonstrating quantum supremacy where a quantum computer performs tasks and it is impossible for a classical computer to check it whether it is correct or not. It's a challenging. Verifying the results of quantum computation is very difficult. I given the example of finding the value of pi. Seventh is limitations to cryptography, security and privacy. Quantum computers can potentially break any password. I have given over here that if quantum computer, suppose I am the CEO of the biggest bank in the world, and one day I keep my password as the Bible, okay, the complete Bible, the complete Quran Sharif, and then complete Gita, Bhagavad Gita, of Sanatani religion. Put it as the password. However, suppose the quantum computer cracks here certain lines, here certain lines, and here certain lines, it can crack the code. It can crack the password. Then, so millions of character password also can be cracked by quantum computer. Then, how to put the password? I mean, these are children-like questions, but these are real questions nowadays the quantum computers are facing. Cryptography, security and privacy. How can you encrypt anything? So, in fact, there are certain phones, for example, of computers, companies, they have, password so much encrypted that even quantum computers cannot crack. So, they have come out with the solutions. Then how to encrypt it, already we saw that one. So how to design the security, how to keep the privacy, that is the question even the governments are asking, companies are asking and how to generate a law for that as well. Okay. Eighth, latency limitations after integration. With earlier version semiconductor chips based computers, latency is a problem. For example, we saw earlier the example of latency that if the satellites are at 400 kilometers over and they are, we are sending data, they are coming back. 400 kilometers is just, 0.01 second, those 0.2 second. In fact, our, the data and talking will happen, that latency is there. Will receive the data after 0.2 seconds. But if it is on the moon, 1.3 seconds delay will be there. That delay is known as latency. Now, quantum computer is there. Delay means latency. Already we saw that. And then normal computers. So it is evaluating faster way, but their normal computers are limitations. So how to solve that latency problem? That is also a big challenge in front of us. While limitations are highly significant, but researchers, institutions, organizations, governments are, actively working day and night over this. so that powerful, reliable, and practical quantum computers we can generate, and then human civilization can become self-reliant, self-sustainable, and we will be able to achieve the sustainable development goals, in fact supreme development goals in future. That is what we should keep the aim. Okay, limitations are there, solutions will also be there, because human beings are always they are finding out the solutions on the biggest problem. We'll find out the solution, but we should implement it for achieving sustainable goals and supreme development goals. That is my request to all. Thank you very much.